Alright, the next chapter that we're going to get into, this is probably going to be the last chapter that we see for this 9 weeks, is chapter 12. Now, I kind of combined chapter 10 and 11 with all the last information, and 10 and 11 are going to help us out with chapter 12. Chapter 12 is called Stoichiometry. Okay, so what is stoichiometry? Well, stoichiometry, definition-wise, relationships among quantities of reactants and products involved in chemical reactions. Okay, what does that mean? Well, layman's term, mathematically finding how much product can be produced in a reaction or how much reactant is needed in a reaction. Now, with these are, what we're doing is a chain mole conversion problem. And I have this generic flowchart that can kind of help us out with figuring out these problems. So we're going to start with an amount of unknown that can be in grams of volume, even molecules or atoms if we have that. And then we go to moles of known. Then we go to moles of unknown. Now, when we go to moles of unknown, this is a mole to mole ratio. And to get to this mole-to-mole ratio, we use the coefficients from our balanced reaction. And then we go to amount of unknown. And once again, amount can be grams, it can be volume, it can be molecules or atoms or something like that. So it's all stuff that we've done so far. We're just combining it all together into one problem. So let's kind of look at an example of a stoichiometry problem. So this one says, how many grams of water is produced when 1 gram of glucose, and chemical formula of glucose is C6H12O6, reacts with oxygen? And we're given our chemical reaction down below. Now what we need to do first is we always need to balance the chemical reactions. So for now on, whenever you see a chemical reaction, think I have to balance this. So figuring it out, well, we have 6 carbons on the left-hand side. We have 1 carbon on the right, so I'm going to put a coefficient of 6 right there. Go to hydrogens. We have 12 hydrogens over on the left-hand side. We have 2 on the right, so I'm going to put a coefficient of 6 to get 12 on the right. Then oxygens. We have 6 plus 2, 8. Now, right-hand side, we have 6 times 2 is 12, plus 6 more is 18. So we need to figure out, how to get 18 over on the left-hand side. Well, if we put coefficient of 6 in front of O2, 6 times 2 is 12, plus 6 more, 18. Now, one of the things that we're going to kind of be doing with these problems to kind of help you out at first, if you look at this generic flow chart, I have known and I have unknown. So we're going to identify which one is which from the problem. And if we look at the first part of the problem, it says how many grams of water is produced. Okay, so since we're trying to figure out something about water, that is our unknown. So I'm going to mark that as U and K, unknown. Then if we look at the second part, when 1 gram of glucose reacts with oxygen. Since we have some information about glucose, that makes glucose our known. So let's kind of go through this flowchart to see how this is going to help us out with the problem. So, in the generic flowchart says we start out with amount unknown. Well, we know that we have 1 gram of glucose. So that's the amount known. Now, the next step is we go to moles of known. So we're going to have 1 mole of C6H12O6 over, and we need to figure out the mass of glucose so we can cancel out the grams units. So figuring that out, we have 6 carbons, so 6 times 12.01 plus 12 times 1.01 plus 6 oxygen, 6 times 16. And I'm coming up with a mass of 180.18 grams. So grams of glucose get canceled out. Now our next step is to go to moles of known, which I said is going to be a mole ratio when we use the coefficients. So this multimole ratio is going to be moles of unknown over moles of known. So our unknown was water, and our known was glucose. So unknown, we have coefficient 6 out in front of water, so we have 6 moles of water over, in front of our known, we just have a coefficient 1. So 1 mole of glucose. Moles of glucose get canceled out. Now, the units get canceled out. The numbers still stay. So hopefully that will kind of help you out as well with this. Then to our last part, amount of known. Well, we're trying to figure out how many grams of water. So in our last ratio, we're going to have, to get to the amount, we're going to have the mass of water. So 2 times 1.01, since we have 2 hydrogens, plus 16, since we only have 1 oxygen. The mass of water is 18.02. And that'll be over 1 mole of water. Alright, so now the unit that we're in is grams of water, and that's what we're trying to find. So we're in the right units. Now we just need to figure out what it is going to be mathematically. So the way that I put this into the calculator, I multiply everything that's up in the numerator together. So the number that we start off with, that the amount of the known, that is up in the numerator. So if I take 1 times 1, hopefully you can see that's going to be 1. Now 1 times 6 times 18.02, and then divide by whatever is down in the denominator. Now if we look in the denominator, we have 180.18 times 1 times 1. So all we have to do is just take our numerator, divide by 180.18. And I'm coming up with 0.6 grams water being produced. That is a typical stoichiometry problem. Let's look at 2 other examples to kind of help you out in this first part. Alright, so our second question says, how much silver 1 chloride could be produced when 125 grams of silver nitrate reacts with an excess of hydrochloric acid? Alright, so let's go ahead and identify what our known and unknown is. How much silver chloride could be produced? Okay, so if we're still having kind of problems with figuring out what chemical formulas of which could be produced, that's telling us that silver 1 chloride is a product in the reaction, which is going to be on the right hand side. So silver, its symbol is Ag chloride Cl. So which one of these has AgCl? Our first product. So that is our unknown. When 125 grams of silver nitrate reacts with an excess of hydrochloric acid. Hydrochloric acid, that's common acid, that's HCl. So our known is going to be the silver nitrate because we know that we have 125 grams of it. So now, balancing the reaction, 1 silver, 1 silver, 1 nitrate, because the formula for nitrate is NO3, 1 nitrate, 1 chlorine, 1 chlorine. So those are all balanced. Then if we go to hydrogen, we have 1 hydrogen, 1 hydrogen. So this reaction is already balanced for us. So let's kind of look at our flow chart once again. Amount of known, 2 moles of known, 2 moles of unknown, 2 amount of unknown. Let's kind of think about that in our head as we go through this problem. Our amount of known is the 125 grams of silver nitrate. Next step in the process is go to moles of known. So we're going to have 1 mole of silver nitrate over the formula mass of silver nitrate. So we need to calculate that out. Well, we have 1 silver, and the mass of silver is 107.87 by looking at the periodic table, plus, then we have 1 nitrogen, mass of nitrogen, 14.01, plus 3 oxygen, so 3 times 16. I'm coming up with a mass of 169.88 grams. Grams of silver nitrate get canceled out. Next step is to go to moles of the unknown, so we have to use our mole-to-mole ratio of our coefficients. So in front of our unknown, we have a coefficient of 1. In front of our known, we have a coefficient of 1. 1 mole of AgCl over 1 mole of AgNO3. Those get canceled out. Then the last step is to go to the amount of unknown. Now we're trying to figure out how much silver chloride could be produced. Now, since we weren't really told what kind of unit, a lot of times we're just looking for the mass. Okay, if it tells you, if it's asking for how many liters or how many molecules, then yes, we would have to use liters. If we're looking at a gas, or if we're looking at molecules, we would have to use Avogadro's number. So in a generic one like this, or just a typical one, if it's asking for how much, go ahead and think, okay, I got to find how many grams. So we're going to put the formula mass of silver chloride up in our numerator. Silver, once again, is 107.87 grams, and then chlorine is 35.45 grams. And I'm coming up with 143.32 grams. Silver chloride over 1 mole of silver chloride. So moles of silver chloride get canceled out. So here's our setup now. Let me show you how I put this into the calculator. Like I said, I multiply everything that's up in the numerator together. So I have 125.00, and I'll multiply that by, now we don't really need to put in ones. If you want to, that's fine, but you don't really need to. Then we have 143.32. I'm going to put those into parentheses, then divide by. And if we look down in the denominator, we only have 169.88. We have 2 ones, but 169.88 times 1 times 1 still comes out to be 169.88. So that's how I would put it into the calculator. 125 times 143.32 divided by 169.88. I'm coming up with an answer of 105.46 grams silver chloride. Let's look at one more example for just today. I will have subsequent videos to kind of help you out with a couple other problems and everything, and some other stoichiometry problems later on. Wednesday and Thursday, to kind of help you out with the assignment. So this one, how many liters of carbon dioxide can be produced if 50 grams of calcium carbonate reacts with nitric acid? So how many liters of carbon dioxide? Since we're trying to find out something about carbon dioxide, that is our unknown. Carbon dioxide, CO2, could be produced if 50 grams of calcium carbonate react with nitric acid. Okay, so nitric acid, we know that acids usually start with hydrogen, so here's nitric acid. This has to be calcium carbonate. That's going to be our known. And let's go ahead and start balancing. 1 calcium, 1 calcium, 1 carbon, 1 carbon. Okay, go on to our next non-hydrogen oxygen element, nitrogen. We have 1 nitrogen on the left-hand side, but we have 2 on the right-hand side. So we're going to need to put a coefficient 2 on front of the nitric acid. Now going to the hydrogens, we now have 2 hydrogens on the left. We have 2 hydrogens on the right. We go to oxygens, we have 3 plus, then 2 times 3 is 6, so 3 plus 6, 9. 2, 3, then 3 times 2 is 6, so we have 9. So So our reaction is balanced. And just like what we did before, we're going to start off with the amount of our known. We have 50 grams of calcium carbonate. We need to go to moles of known. So 1 mole of calcium carbonate over. We need to figure out the mass of calcium carbonate. So calcium 40.08 plus carbon 12.01 plus 3 oxygens, so 3 times 16. And I'm coming up with 100.09 grams. So grams of calcium carbonate get canceled out. Next step is to go to moles of unknowns. So our mole-to-mole ratio, well, if we look in front of our unknown, we have coefficient of 1. In front of our known, we have a coefficient of 1. So 1 mole CO2 over 1 mole CaCO3. So moles of calcium carbonate get canceled out. The last step, the amount of our unknown. Well, we're looking for how many liters of carbon dioxide. Carbon dioxide is a gas. And if you remember from the video that we were talking about with mole conversions, we know that 1 mole is equal to 22.4 liters of a gas. So we're going to be using 22.4 liters CO2 over 1 mole CO2. Mole's going to get canceled out. So here is our setup, and let's go ahead and run that through our calculator. We're going to take 50 times 22.4 divide by, and then down in our denominator we only have 100.09. So I'm coming up with 11.19 liters of carbon dioxide. Okay, so this first video is going to kind of be able to help you with some of the problems on the assignment. As I said, I will come up with some other videos to kind of help you out with later ones. I don't want to overload you at the beginning. If you have any questions, please email me, and I will talk to you later. Thank you.